Hello, everybody. This is Nick Terrell, Professor of Information Technologies and Computer Science, Lakeland Community College. In the first two videos of this series, in the first video, we talked about just general errors. We had syntax errors, we had logic errors. It was more important in this point in time in this course that we talk about exception handling, trapping, things like that with the try statement, try except using Python. This video is going to take those concepts from the first two videos, actually more from the second video, and expand upon it and begin to talk about secure programming techniques. Now, in the second video, I ran through a series of programs, and if they worked, they just completed and then they were done. If they didn't work, they would throw an exception, we would handle the exception, and they were done. In secure programming, we never want the program to abort and end us back into the operating system. Now, there's generally two ways that we can prevent that. One is through the trapping of exceptions, catching those exceptions, and then just cycling through. The other way would be if there was an abort, an unnecessary or unexpected abort, it would just reboot the program. That's not for this course. So in this video, I want to begin to talk a little bit about some cybersecurity issues and secure programming tactics and trapping exceptions, capturing exceptions, and then continuing on or maybe looping through is one of our first avenues that we'll take. When we're developing code, we oftentimes use test data to make sure that we're getting the results that we want. We also will rely upon what we call fuzzy or fuzzying the code, where we introduce bad data. And when we introduce the bad data to the code, we're looking for ways that if we break the code, what does the code do? We do this a lot in cybersecurity. This is even kind of a little offshoot of what we call SQL injection. So fuzzing the code, applying data to the code that we know will break the code or potentially break the code so we can go in there and fix it. So test data is normally thought of, we're giving the code data, test, and we know what the results are going to be. Fuzzy data, we're seeing if we can break the code so we can then fix it before we release. I'm going to use the same set of programs. I've added a couple more and use the same set of programs that I used in the second video to walk through there. So let's go up to my screen and let's walk through a little fuzzy, a little secure programming techniques. All right, I'm going to go back. The first thing I want to do is I'm going to go back to the very first program. And if you saw the first video, I kept it simple. We asked for weight and inches, both numeric values, and then we divided it to come up with the BMI. I said, this program works. There's no logic problem to it. There's no syntax problem to it, but it has problems where if I give it a string as a value, it's going to cause an interrupt. It's going to throw an interrupt. It's going to throw an exception. And if I divide by 0, it's going to throw an exception. But even if it works, it's just going to run through, work one time, and then it's done. So let's run the code real quick. So it's asking me my weight, 265, height in inches, 75. The program worked. It's waiting for the last keystroke, and then it's done. We wouldn't normally, if this was an app, on our phone, we don't want the program to stop into the operating system. So one of the little techniques we can do for demonstration purposes, I can go back into this code and I can basically throw it into a loop. Don't worry about the OS and the import OS. That just clears the screen. I'll talk about that more in a bit. But basically, I have a loop in here called the while loop, and I always set it to true. And what that means is just constantly loop through this program. When you're done, loop through this iteration. When you're done, start over. When you're done, start over. To get out of the loop, we would have to do a break. We could either program a break, and we'll do that in a demonstration in another program, or I can do a Control C from my keyboard. But all this is going to do is loop through this program. So now let's run it. And if I put the weight and the inches and we loop, then we just loop through. It's at this point where we begin to think about secure programming. We want to control how this program ends. We want to control it. I could hit a control key and it will end the program. I don't want bad data to control this program. So now if I put the weight of 265 and I throw height as a 0, there's that divide by 0 exception. It's going to throw that exception and it's broken. This in secure programming, this would be a bad thing. This is the data forcing the program to do something we don't want the program to do. When we're talking about fuzzy data or fuzzying the data is we can be throwing a lot of different combinations of the data, and if it breaks, that's bad and we fix it. So again, this is what I'm attempting to do. I just want to use the very first one as a simple example. So I don't ever want to fall out of the code. I want to control that situation. So now let me go to this program here. It's just the next iteration of the code. I've added a couple things to make it a little bit clearer. The first thing I did was I'm importing the OS module. And the OS module, if you look right here, the OS module will allow me to clear the screen after every iteration. So it'll clear the screen, it'll ask me questions, loop through, clear the screen, ask me. Not a big deal. It's just more for aesthetics than it is for the actual code. What this code does, and you have to watch the first two videos to understand the try and the except blocks. What this basically does is we have this try, says try the weight, try the inches, try the BMI. Basically, you got to give me valid data. If you don't give me valid data, if you give me string data or you divide by 0, I'm going to throw an exception. And then it will throw the exception like you're having problems here. It's going to alert me back to the screen. I threw in another set of lines here called the keyboard interrupt. What that does is at any time I can break out of the program by just hitting Control C, but I'm controlling that. I'm controlling that particular environment. This is for demonstration. So the key to this demonstration is that if we give it good data, it will run it, and then it's going to cycle through, it's going to loop through, and we can keep on giving it good data. And at no point do we want the interrupt to break us out of the program. If there's anything about this program that's key is we don't want bad data interrupting sending us to the operating system. Because in cybersecurity and secure programming, if my program drops me off into the operating system, really bad things can happen. This is what some pen testers and what bad actors do. They will clobber applications with code, with data to see if they can force it to break, and if they can break it, if they can interrupt it, and then they can get into the operating system, bad things happen. So again, this is a little bit of secure programming. The first two videos we talked about logic. I said, you know what? Let's expand upon it and let's talk about a little secure programming here. Key concept here, we keep iterating this. Key concept here is we don't want an interrupt, we don't want an error, we don't want bad data dropping us off into the operating system. The only thing that we want to drop us off to finish the program is a controlled situation. So let's run this code. How much do I weigh? 265. How tall am I? 75. I got a BMI of 33. Yes, I'm overweight. I hit enter. It's asking me again. So now I can start feeding it bad data. The first bad data I'm going to feed is I am 0 pounds, and I am 75 inches. It says the BMI is 0 because the calculation said, take the height divided by the square of the inches times 703. So this did not throw an interrupt. This did not throw an exception. This basically did the language. So we would go in there and fix it. All right. Let's throw in some more bad data. Weight, 265, and height of 0 inches. This threw an interrupt. This said you can't divide by 0. Remember, the BMI says weight divided by height square. If I give it a 0 for the height, then it's dividing by 0. And we threw an interrupt. So it told me what was going on, but it didn't kick me out of the program. So I hit enter, brought me back to the loop. So we know that we're hitting interrupts there. It's working. If I say, okay, my height is 265 and my height in inches is X, I'm giving it a non-integer or a non-numeric value. It threw another interrupt. It says, wait a second, you have to give me number values. You can't give me a string. So this is now working. This is pretty solid code. The only way that I can get to the operating system, it's a very simple code. The only way I can get to the operating system is if I control that. In my particular environment, I just say Control C, but there could be a wide variety of things. So we never want to be dumped off to the operating system. We want to control the situation, because if a bad actor or a pen tester can get to the operating system, get to the command prompt, really bad things can happen. So if I break out of this code, then I'm back. But I've controlled it. The users controlled it, not the data. Let me run this program again. And this time, let's dive a little deeper into cybersecurity. If you go down the cybersecurity track and you take my ethical hacking course or any kind of course involved with cybersecurity, you learn the greatest asset to a pen tester, the greatest asset to a hacker, to an ethical hacker and unethical hacker, is the gathering of data. The more information they can gather, they keep little books, they keep records of things. The more information they gather, the more they can find ways to pen test or invade your system, to compromise your system. So many times when we write code or we do something, we don't want to feed information back to the user, to the pen tester, to the unethical hacker. In this program, it worked. But I wouldn't recommend this program, because this program actually is providing too much information back to the pen tester, the unethical hacker. For example, if I give it valid data, we know that it's working. So we know the calculations. Pretend I'm a pen tester now. I know we have valid data here. If I give it invalid data, where the height is 0 and the weight is 75, this is actually valuable information. This is telling me whoever wrote this code didn't do a good job. They should have put some kind of prompt in there saying you have to have a valid height, you have to have a valid weight. They did not. This tells me as a pen tester, this is poorly written code, because it's providing me information even though it's not providing me information. It's saying you're running this, here we go. But more importantly, this is minor compared to this. If I do a divide by 0, this code just told me a lot as a pen tester, as a unethical hacker. This code told me that whoever wrote this code decided to let me know the exceptions, right? So now I know as a pen tester, this program is trapping exceptions. That's interesting. In the first two videos and course lecture, I talk about there are many, many exceptions that we can potentially trap. Let's say, for example, let me paint a picture here for a second. Let me paint a picture. We find out through the different dark areas on the web that exception 273 has a vulnerability to it. The programmers aren't aware of it, but the bad actors of the world are aware of it. So exception 273 has a vulnerability associated with it. So I start throwing or forcing this program to throw exceptions. And if I'm getting these messages, hey, this exception was thrown, but I'm going to loop you through. This exception was thrown, but I'm going to loop you. And all of a sudden I do something. I add data, I put data in there that throws exception 273 as a pen tester or an unethical hacker. I've just discovered a vulnerability. So again, the gathering of information, the methodology associated with gathering that information and saying, I know you're throwing exceptions because you're telling me you're throwing exceptions. Let me use that information against you. So I'm going to break here and I'm going to go to the last program in this series. In this program, I've cleaned some things up, right? It's still not the most sophisticated program in the world. Let's be honest with that. It's not graphical, but it's easy enough to understand. Basically, yes, I'm going to loop through until I do a control C, till I control the break. That's not changed. I clear the screen at the beginning of every iteration. But now what I've done is I've opened up a log file. I've opened up the log file that instead of sending that exception to the user and letting somebody know you're throwing exceptions, I'm going to write those exceptions into a log file so administrators can look at it. That's what log files are. Most log files are some kind of information that the administrator has to be aware about. So in this particular code, I've only changed one thing. Instead of printing the information to the screen, sending it to the screen, I write this information to a log file where the end user, the person who's trying to break it, won't see it. So let's run this program now. Okay, 265, 75, we know that works. Let's start throwing exceptions here. 265, inches 0. Oh, nothing happened. I'm not aware. It didn't show me the exception to the screen. That's good, but it didn't come back with the BMI. All right, do it again. Nope, it's not letting me what's going on. What if I give it more bad data? Instead, 265 divided by y. All right. Nope. It's not providing any information. That's the key here. We're not giving the bad actors or the pen testers key information here. And I'll do it one more time. I'll say, wait. You can see that it threw an exception right away. The moment I gave it bad information, it threw the exception, but it looked me through. Programmers know, hackers know that these programs have to trap these exceptions. They're not idiots, but what they're trying to do is find out how you are doing it. And that's key to them. What are you trapping? What error codes are you throwing? And how are you doing it? They know, good programmers know how to do this secure programming. Pen testers, unethical hackers, bad actors of the world, they know how this stuff is done. They're trying to find weak programmers. They're trying to find, are you still providing me information? So after this program's run, let's take a look at the exception log. And here is the exception log. The bad actors would not have access to this exception log unless everything's really a mess. But you can see, instead of sending it to the screen, we write a log, and here are a series of exceptions. I ran this program before, so these first 4 lines are just saying this is the errors that I had before, and the program ended normally. And then here's what I did for this demonstration. We tried to divide by 0, didn't work. Tried to divide by 0 again, still didn't work. Sent Y for the height, that didn't work. Sent the word weight for the weight, that didn't work. And then the program ended normally. So let's wrap some things up. There's a lot of things involved with secure programming. This is just one of them. It's not, I won't say it's the most important thing, but it's just one of them. It is the concept is really, You as the programmer want to control the program and what the program is doing. You want to, there's a lot involved with fuzzy data, but you want to provide a data to see if you can break it. You want to provide a data to see if you can trap it. And if you can break it, you want to fix it so you can't break it. The worst thing that a program can do is abort itself and drop you off into the operating system. Then the program is acting in accordance with the data and not acting in accordance with what the end user is attempting to do. So, beginning of some key concepts here. It was something I forgot to show semesters ago. I figured I'd just add it here. So, just a third part of this video series. This is secure programming, or beginning of secure programming. So, with that being said, let's go out and learn something.